It's my first time presenting in a place where they usually play, what is it, soccer or football? What do you call it? Football, okay. Someone asked me in the elevator, they said they were wearing a Swedish geek shirt. And I said, wow, are there Swedish guys here? And he said, I think I'm the only one. Are there any Swedish guys here? Or girls? Okay, there are at least one. You're the same guy? Two? Okay. I'm sorry for you. Okay. Good morning. I really appreciate the fact that you came all the way over here in such an early morning. Well, for me in Israel, it's considered really early to be up at 9. I know for you guys, since it's light since 3 a.m., you've been working for 5 hours now, right? I was consulting here for 2 months a few years ago. And I was working almost a regular job, daily, going every day to work. And it was from December and January. And it was dark. And it was a great feeling, okay, a really greatly weird feeling, to get up and it's nighttime, to work and it's nighttime, to go to bed and it's nighttime. And I understand why you guys are so quiet and always like to be in your house. It's very cozy there. And if you'll notice, only warm countries are the places where people let themselves really, they let go. Like Italians, it's really warm there. Hey, whoa, how are you? Hey. And Israelis are the same way. And Greeks as well. So every country that's warm, you're going to see people like a bit crazy. Because it's warm. They're angry. And here, you don't really have problems. You have a lot of water. It's nice and cold. Some snow even. Just a bit dark. That's it. Okay. Now that I've moved some time. My name is Roy Osherove. I work at a company called Typemock. I'm the chief architect there. We work on the next generation of unit testing tools, but this is not a commercial, so I'm just going to skip that. You can read my blog at icrealizable.com. And if you want to follow me on Twitter, it's Roy Osherove on Twitter. You will find amazing quotes there like, I can't believe I'm up this late. My cat ate my tests, and so on. It's really bad. How was Metallica? Was anyone there? Come on, who was in Metallica? 1, 2, 3. Any Swedes in Metallica? What? Great audience. Just so you know, I have an upcoming course with the company that is arranging this event. And it took me a few years, but I learned how to say their name. It's called Programutvikling. Right? Yeah, thank you very much. Now, if you go to this tiny URL /TDD August, you're going to find all the details if you want to register. It's on August 24th, which is supposed to be just after my birthday, so I expect you to come cheerfully and with presents. I also have a book out, just released in the past month or so. It's called The Art of Unit Testing. And I'm happy to say that this is the first time I've seen it on sale. So it's actually on sale here at the conference. So if you're happy with the stuff that I'm talking about, just so you know, this book contains everything that I talk about. Sometimes I expand a little bit in the book, more than I say here. Actually, a lot of times. Because there I had more time to write my thoughts. This day, for me, is going to be really interesting. I have 6 talks. Never done 6 talks in one day. But they're all basically on the same pattern. We're going to start with Introduction to Test-Driven Development. Thank you, Uncle Bob, for telling everyone to go to my talk. Then we're going to continue to Unit Testing Best Practices, which are both going to happen in this hall. Then I have a talk called Beautiful Teams. It's based on a book called Beautiful Teams, but it also talks about team leadership. And it's going to be, I think, at number 6. After that, hopefully we'll have lunch. Then we're going to talk about more advanced subjects in unit testing, such as mock objects. I'm going to show some mock object frameworks like RhinoMocks, Typemock Isolator, and Mock. And I'm going to explain the concept to anyone who's never seen or just heard the term, you're going to get it after this talk. The last two talks are a bit on the extreme side. They take you to places in unit testing where people have not gone before, as far as I'm concerned. The mocking on the edge is a talk that's it's a 400 level talk. It says 300, but it's 400, and it explains how to create a different kind of isolation at the system level, not at the test level, where the system is isolated or stubbed out by default. And the last one is going to talk about Silverlight and how to write unit tests in Silverlight using either the MS Test unit test framework for Silverlight or Silver Unit, which is a framework that I wrote. And we'll talk about the differences between them. Anyone here program in Silverlight, by the way, by raise of hand? Okay, quite a few, 5 people. Okay, you'll get my humor later. We have several things on our agenda. Let's just start with, what does test-driven development mean? It's interesting. Test-driven development, to different people, it means different things. And when people say, yeah, we do TDD, we're test-driven, sometimes they mean different things that I thought they did. So at some point, I just started writing out what they really mean. Came out to 4 different types of explanations. Some people, when they say test-driven development, they really mean test-driven development. They write the test first, before they write the code. Some people say we're test-driven, but they just mean we're test-oriented. We have a lot of tests. We don't necessarily write them before we write the code. Some people will say, oh, I don't do test-driven development, I do test-driven design. This is what I call purists. These are people who believe that not only does TDD allow you to better your design, they believe that test-driven design can start with no design whatsoever. So you want to create a system, you just start with a test. You don't even start with an existing design or even a basis of a design. Some people can do that. A lot of people don't. It's really hard to create or to get people who can create a design just in their head. And I think most people say we do test-driven design on a pure basis, that is, no design whatsoever. I think what really happens is that in their minds, they actually do have a design. They just don't write it down. And they just map it out with tests as they work. And that's okay. I don't think a lot of people can do that, though. The last one is where I'm usually at, where I do test first, but I also let my tests change the design. But I don't necessarily start with no design whatsoever. I may start with some design, with a basic set of APIs or just squares on a whiteboard, and then I would implement them in a test-first manner. Now, as I implement them in a test-first manner, my design might change again, because one of the things that you'll see is that when you write test-driven in a test-driven manner, you are a customer of your software, and you realize that your API may suck, or that your design is not usable enough, and you will find a way to change it because your tests tell you to. And in a way, I really like this. It's really comforting to see that a lot of people really enjoy this, because at some point I thought I was, when I was just starting out, I was the only one in my company who was doing this kind of stuff. And people were like, what? No, you're changing the code because of the test? That's crazy. We'll see some of that. Now, TDD does have a place where people put it in some category, and usually they put it in the category of agile development. It's usually connected to a methodology called extreme programming, which is under that category of agile, and it has a lot of practices. A lot of them are technical practices that developers will do. One of them is test-driven development. It actually tells you to do test-driven development. The nice thing about TDD is that you can take this practice and do it regardless of the methodology that you use, because it's something that connects just you and your computer. You as a developer can decide to do this, just like you as a developer can decide to do debugging. No one tells you when to debug your code, right? Well, maybe, hopefully. But just like that, no one can tell you if you want to write the test first or not. It's your personal decision. That's why when people tell me, no, we can't do TDD in our place, because someone doesn't want to, someone doesn't let us, it's usually, I can usually detect a way for them to still do it. But they don't realize that the choice comes from within, not from the outside. I'm not going to get all psychologists on you. I'm just saying, if you really want to, you're going to be able to do it. Now, before we start with test-driven development, we need to understand what a unit test is. So just so I know how fast to go on this, how many people here have seen a real unit test? Okay, about 30% have not seen a real unit test. So I'm going to explain this quickly so that everyone gets up to speed, because this is the basics. So a unit test is a piece of code, an automated piece of code that checks another automated piece of code. It really invokes that other piece of code. So imagine we have a function called isLoginOK. Now this font is not too small, right, for the people right up there. If it's too small, please yell, it's too small. No. Okay? Because, you know, I have this software that does zoom. So if you were to yell, it's too small, I were to help you to see what is written. So it's your choice if you want to help yourself. Is it too small? Okay. So we have this function, isLoginOK, returns a Boolean, for those who can't see. Now, it takes a username and a password. And of course, there's some code in there. So I would probably have a test that checks, calls it with some parameters and checks that it returns true. Calls it with some other parameters, checks that it returns false. Now, how many tests could I actually write for a method like this? Does anyone know? Does anyone have any guess? How many people think they could write maybe just 2 tests? Okay, that's good. You knew I was going to say more, right? How many people think you can write maybe 4 tests? Okay. How many people think you can write about 6 tests? How many people think more than 6? More than 10? More than 12? How many do you think, sir? It depends, okay. I can't hear. I just heard the first 2 words. Well, it depends, of course, but how many at least? Okay. Well, I don't know either. I'm just asking to see if we have a consensus. And let's say the consensus is most people, well, when I asked if more than 6, about 10 people raised their hands. When I asked more than 10, 2 of them lowered their hands. And that means there are at least, I think, 50 people here that are just not listening to me right now. Because you should have, you know, no one raised their hands about in 2 tests. No one raised their hands in 6. You have to start listening, people. I'm too far or it's too low, the sound. Something has to be off here. So let's assume that we have at least 4 tests. 2 for the Boolean, and then probably some invalid values, or maybe, and then there's some real logic in there, other than just username and password. Like username is in database, but the password is wrong, and so on and so on. So there are definitely at least 4 use cases here. So this is one function with logic, when you can write 4 tests for it. How many functions like that do you think you have in a real software project? At least. I'm talking about a regular one, not a small one, not one too big. How many people think you have more than 100 logical units? Okay. How many people think more than 500? Okay, quite a lot. More than 1,000? Okay. So the consensus is more than 500. So I'm going to say 300. Let's say it's a really small software project, you have only 300 of these logical units. How many tests would you have in such a project? Times, what, 4? That's 1,200 unit tests, at least. How many people here have unit tests in their applications today? Okay. How many people here have more than 500 unit tests in their applications today? 3, 4, 5. More than 600? 3, more than 700, 1, 1.5. Okay. Most people will not have more than a few hundred tests, and they will still say that they're doing unit testing and test-driven. Now, I'm not saying that's necessarily a bad thing. What I'm trying to ask is why. Because if we all agree that we have a bunch of logic that we need to test, and there are a bunch of use cases for each one, at least, then we need to have at least a specific number of tests. And yet we always get to a lower number. One of the reasons that a lot of people have a lower number is that A, they don't have time to write the tests because they write them after. B, it's maybe too complicated to write those tests. But just imagine you had these 1,200 tests. So you have a real application, it has 1,200 tests. Are these sentences true? Is it easier to find bugs when you have 1,200 tests in your application? Who thinks this is true? Okay. Who thinks this might not be true? 1. And you were just doing like this, okay. So here's why it may not be true. And those who've really written unit tests will agree. What happens when you have bugs in your tests? Oh, then you think maybe they pass, but they actually have a bug. Then it takes a long time to find those bugs. So yeah, finding bugs in the test is a horrible, horrible procedure. So this may not necessarily be true. In fact, a lot of time it's not. And one of the main reasons is because people write a lot of logic inside their unit test, and unit test should be very simple. This is something I will also cover in the next talk. So this is not necessarily true, but there are ways to make it true. Is it easier to maintain your application when you have 1,200 tests? Who thinks this is true? Okay, maybe 15 people. Who thinks this is not true? Okay, 25 people. You see how I count really fast? Now, the reason this is not necessarily true is very simple. Just imagine that you have a test that creates an instance of some class. Let's say it's calculator. And you have 25 tests for that calculator. And now you go and you change the constructor for the calculator. Now you have 25 tests that do not compile. Now you have to go and change each one of them. So maintaining the application, changing its code, may actually break a lot of tests for the wrong reasons. They may not compile now and so on. So maintenance is actually, most of the time for most people, is actually harder when you have more tests. But there are ways to make this true as well. And this is through reusing code, refactoring in the tests, and so on. And also something that we will cover throughout the day. And the third one is it easier to understand the code when you have 1,200 tests? And when I say this, most people don't understand what I mean, understand the code. Well, just imagine that you're a new developer in the company and you are tasked with finding and fixing a bug in a specific class. Now, you've never seen this class. It's a huge class. There's a specific method where you're told the bug is located. But you have no idea what it does, how it works. The first thing that you do is... Anyone? Look at the test. No test, I'm sorry. What do you do? What do you do? Look at the code. Well, what I would usually do is really try to find all the references for that method in the code and see how it's being used. What are the use cases for that method? So that I know in which context it needs to be checked, what it's supposed to do, and so on. But when we do automated unit testing, you can think of each unit test as a small use case, an automated use case that tells you what a method or a class or a bunch of classes should do in a specific scenario. But also, this may not be true, because most people, when they write tests, they write them in an unreadable manner. When I say unreadable, I don't mean that they obfuscate code, but I mean that they don't give attention to the naming of the test or the naming of the variables in the test. And it's really, really important, because tests are not just automated tests. Think of them as API documentation, executable documentation. And if you think about them like that, you realize that the naming is really important. But most people have names like test login 2, test login fails 3, and so on. And when suddenly that test fails, someone looks at the test and realizes that they have no idea what the test is doing. When should it fail? Why would it fail at all? So they start looking at the code for the test. They have no idea what they're watching because the code is hard to understand. So they start to debug the test. And suddenly, just because you have tests doesn't really help you because you still have to debug and understand the code. There's very little value in that. And of course, you can't maintain the test this way because you don't know what they do. Now, if all these things are true, it's easier to develop. And of course, making it easier to understand is very easy to do. You just keep a bunch of naming conventions in check, and you can do that. Now, when I talk about test-driven development versus just unit testing, there are people who believe that TDD is the answer, is the ultimate answer to whatever our problems in our software are. Can you guys read what's going on there, by the way? Okay. You didn't say no, so I'm good. TDD does not help with the maintainability of tests. That is, I've seen people write test first and write really crappy tests. And they do not help with test readability. So you can write a test first, but it will still not be understandable. And these are two very critical facts that we will need to learn regardless of doing the test first or after. So learning good unit testing and learning test first are two different things. You can learn how to do proper unit testing and then learn how to do that testing before you write the code. These are two different skills. When people say TDD and they mean both, but I want to separate the two. That's exactly why, for example, the book that I wrote is specifically about unit testing. It's not about TDD. Some people say it's a TDD book. No, it's not. It doesn't even say TDD except just in the first chapter where it says it's not a book about TDD. This is really important because most books today about TDD also try to cover proper unit testing, but because they try to cover both, they go empty-handed in both sides. So I think that learning proper unit testing, learning test first are two separate skills. And in fact, if you learn them together, it's really hard. It's really hard because you need to learn also how to do proper design because TDD drives your design as well. So there are skills that you need to learn. Now, if you do test first, you do get a lot of benefit. I'm not saying TDD is a bad thing. In fact, I think it's a very good thing. TDD does help with creating tests that you can trust. Now, if you don't trust your tests, you will not run them or you will not believe their results. How many people here who actually have tests have ever heard this phrase? They see a test fail and someone goes and says, and this is the worst thing to ever hear, oh, it's okay, it's supposed to fail. Anyone ever heard this in their company? Okay, several people. This usually is a really bad sign because tests should not fail by default or expectedly fail because then you don't believe their results. What if they fail for the right reason, not for the wrong reason? So we'll talk about that as well. TDD helps with design. It does help with your design. It should not, well, I hope it does not force a specific design on you, but it does give you smells where you can say, okay, I want to design better in this case. It does provide the understanding of a specific problem. So when you do TDD, you do really small tasks, and then you start solving them one by one. Code coverage is much better with test first. I mean, you could get to 100% code coverage of code with logic. I specifically don't test code that has no logic. And logic for me is anything that has an if or a switch or a loop. Anything else like just regular properties, I will not write a test for. They have no logic. If a property has a logic, I will write a test for it. Now, there are a lot of other benefits, but the main three written down below. Now, that when a company does true test-first development and they implement by feature, not by layers, they will be able to do real incremental development. They will always have a piece of working code that they can show someone. So instead of something taking 6 months, you will have something to show within a week. Doesn't necessarily have a UI, but there is some functionality there. A team will be able to deliver early and often if they do test first, correctly. And the reason they can deliver early and often is because we test first. You always make something work before you make another thing, a new thing. There is always a test that fails, and you make it work immediately. That means that you immediately have new functionality in your application. So if your boss comes to you and says, so what's the status of that task? And you say, it's 50% done. It's not like today is 50% done. It's really actually 50% done. You can actually show the test that it actually 50% works. And when it's 100% done, you can actually show all the tests for that. You don't get to a situation where it's 90% done, and then there is another 90% to do. This is something that we all struggle with. But with this, you actually have these tasks that you need to follow, and these are executable specifications. And of course, the code quality is much higher. Now, most people that I know, in fact, all developers I know, do unit testing. Because I don't know a single developer that doesn't check their code before giving it to someone else. But most developers don't do it automatically. They don't do it repeatedly. For example, tell me if this ever happened to you. As a developer, I would write these big big forms with a bunch of buttons on them. They would be called button 1, button 2. They would be random, like a Picasso painting. And there would be like text boxes, text 1, text 2. And when you click them in a specific order, and you fill the text in a specific order, and you click them, you would know the application works by any message boxes. Anyone here ever done that? Okay. So a lot of people have done that, and the other half are just either shy or asleep right now. Now, this is not a bad thing. This is a very good thing, because there are some people who don't even do that. But the difference is that most people in your team will not be able to run those same tests that you're doing manually. And you want people to be able to run your tests. Why do you want them to run your tests? Because you want to know when they broke your code with their code. You want to know when you broke their code, so you want to be able to run their tests as well. So as developers, we want to run everyone else's tests whenever we want to. And if you write these WinForm things, you don't get that. So you want repeatability. You also want to write them all the same way so that people know how to write tests. You don't want to reinvent the wheel. A reason that a lot of people don't write a lot of tests, they just write tests for only the really specific scary stuff, is because it takes a lot of time. Because if I could tell you that you can write a test for something in 30 seconds or a minute, most people will say, yeah, I would probably write more tests. But we don't have the time for that, because it's really hard to write those tests. But if there was a framework that allowed you to write those tests in a specific manner and to run them in a repeatable manner, and we would know how to write them, then we'll probably write more tests. And those frameworks are what's called the unit test frameworks. And there are a bunch of them. They're called by default the XUnit frameworks. The X stands for the first letter in the language. So for Java, it was called JUnit. For .NET, it was ported to something called NUnit, which is what we'll show today. And there's basically one for each language. Most of them are open source. There's also one which is not, which is the Microsoft unit test framework. It's called MS Test. It's not a bad test framework. It does have some problems, but just so you know, if you need to decide which one to use, let's say NUnit versus MS Test, the choice is very simple to me. If you have team system already in your company, by default, I would suggest you use MS Test, because it does come with a lot of benefits into the team system stuff, a lot of integration stuff. And really, the big differences between the frameworks are not that big. They're very simple things. A framework is just a bunch of attributes and a runner that runs them. And once you get the hang of it, changing frameworks is really a simple matter. So a framework, by default, use the framework that's closest to you technologically. Most of them are basically the same. Some of them have some extra stuff, but you can always use mix and match if you really wanted to. I'm going to use NUnit because it's one of the most widely used. Now, all these frameworks provide three things. You can write tests in a specific way, you can run them, and you can review the results if they failed. You can see where those tests failed. Writing a test with NUnit is a very simple matter. It's just writing a method that doesn't take any arguments, and it's public. It doesn't return anything. The big difference is it has a specific attribute on it called test. This is part of the NUnit framework. If you're using MS Test, this attribute would be called test method. Now you are already seeing the naming convention that I usually use for unit tests. Let me explain that a little simpler. You guys in the front row, you're gonna love this. Okay, so we have those, we have 3 parts in each name of a test. That's what I usually do. The first part is the name of the method under test. It's really important to have the name of the method under test because some tests will call multiple methods. You want to know which one is the one that has the logic under test, or where does it start. The second one is the scenario. So if you think about like an English sentence, it would read, when calling some with or when an overflown input, then the third thing happens. The third thing is the expected behavior. So there are 3 things. If you miss just one of them, the reader of your test, remember this is API documentation, is going to have a hard time figuring out what it is you're writing. Now most people, just imagine that login method I talked about earlier. Imagine that the test name would have been test login. Now I have several problems with the name of something called test login. First of all, you don't need the word test in there. Why don't you need the word test? It's very simple. I know it's a test. No need to tell me again. Remove that. Second of all, it tells me what's being tested, doesn't tell me how it's under what scenario or what's the expected behavior. I now need to go into the code of the test and understand what it is that's supposed to happen. So I now may need to start debugging the test. If the test name is good enough, I shouldn't even need to look at the code of the test. Now this is even more important when you consider the fact that test names are basically the single output of running all the tests, and so some of them fail. For example, you have 1,200 tests, 12 of them fail. The first thing you see is the name of the tests. You don't see any comments, you just see maybe a stack trace and stuff like that, but you just see the name of the test. So anything that's not written there, you're going to have to go into the code and start looking at that. And I want to be able to just look at the list and say, I know where the bug is. I know what the problem is. And in fact, when tests are written correctly and in a readable manner, a lot of time you won't even have to start debugging. You can actually go to the code, fix that, run all the tests and see what happens. You will see that a lot of debugging time will be removed just because you have good tests. In my class at TDD, I usually ask the students at the beginning, well, I ask them at the end, how much debugging have you done during this course? Most of them will say that during a 5-day course, and most of the 5 days they just sit and program stuff. They debug less than maybe 10 minutes throughout a 5-day course. And that's about at least 4 hours of coding each day. So this is a big impact. This is a real test case in that it has real code in it, but it's still a really bad test case. But it's good for demos. It's good to explain stuff. A test case is, again, something with a test on it, but it has 3 parts in it. The parts are arrange, act, assert. The 3 A's. And you're going to hear that more and more throughout the day. The arrange part is where you create instances of the stuff that you're going to test. In this case, it's called a calculator. Then you act on that stuff that you want to test. You call a function on it or something like that. And the third part is asserting that something happened. If you don't assert, your test will always pass. It's meaningless. So you have to assert something. Some people write tests and just check that there is no exception thrown. And that's a way also to do an assert. But you would write these tests, it's more of a smoke test, really. It's not a unit test. A unit test checks specific behavior. Not throw an exception is not a behavior. A behavior is something that you do, not something that you don't do. Okay? Something that you don't do always corresponds to something that you do. There's always 2 opposites. So I want to see that it does this if A happens. It does not do this if A does not happen, or something like that. You can't just have just the second one. Now, the assert class is part of all the test frameworks. There's a class called assert. It has static methods on it. This one is called r=. And the first parameter is the expected value. The second parameter is the actual value. And the third one is the message, which will be output into the screen if this test fails. Now, most people will not write the third one, will not write that string. Or if they write the string, they write it as if it doesn't really matter. So they just write, like, they paste in the name of the method or something stupid like that. Because they get lazy. So I'm here to tell you that you don't even have to use that parameter. I don't use it. If I have a good name for the test, the third one is pretty meaningless to me, because the test name should say everything I need. In only very rare cases would I need to write a string there in very complex logic. But most of the time, if the test name is there, the third parameter of the assert is not needed, because I have the scenario and what's supposed to happen. If that failed, I know what the problem is. I don't need the message to tell me. So this parameter exists because at some point there wasn't any naming convention for unit tests. Now, this is not the only naming convention. There are others. This is the one that I personally use. And I would recommend that you start with something. This is the simplest one that I know. And once you feel comfortable with it, you can move on to other things. There are also other ways to arrange tests from what I'm going to show. But you have to start with something. And as you feel comfortable with that way, you can move on to other ways. But you have to realize that you've outgrown a specific way of working. So you have to work with it first. You have to try it. It fits most people, especially as they are learning stuff. I still use this way today. Yes, sir? Multiple asserts in my method. I will touch on that on the next talk. Or you can buy my book. I'm sorry, what? It would be a good idea to use a comment with multiple asserts. I will touch on that on the next talk. But usually I don't write multiple asserts. I don't need to write comments in my tests. If I need to write a comment in my test, something is wrong. Either the test is not readable, or I have multiple asserts. Usually when you have multiple asserts in your test, by the way, you won't find a good name for the test. That's also a good sign to know that something is wrong. Because the test only tests one thing. Multiple asserts means you're testing multiple things most of the time. Now, that was unit testing. Do you want me to show you some tests before we continue? Who wants to see some tests before we continue? Okay. Yeah, let's see some code, dude. I'm sorry, it was let's see some code. No, I just came from Vienna. That's how it sounded there. Sorry. Okay. So, hey, is the code too small for you guys? Are you okay? Yeah. Yeah, we don't care. Just show me the tests. Okay. Just so you see the basic setup, I have two projects here. One is called My Product. The other is called myproduct.tests. This is a class library. It's a regular class library. And in the references, I have a reference to nunit.framework.dll. That's all I need to get started. And of course, I have a reference from the lower one to the upper one, so I can test my actual product. Now, in my product, I have a class called stringcalc, and I have a corresponding class called stringcalctests. Now, stringcalctests will contain, obviously, the test for stringcalc. Some people do not organize tests this way. I recommend it to get started, and when you outgrow this or you find other ways, you can try them as well. Now, the class itself looks very simple. This is the test class. I will show the production code in a second. A test class will have an attribute on it. With MS Test, it would be called test class, which I think is more readable than NUnit, that took the name from JUnit, where it was called fixture. So this is a test fixture. I just think of it as a test class. Just makes more sense. And on the method, we have the test one. Now, without seeing the code, the production code, I should be able to understand something about the code being tested. Let's look at the name of the first test. Length without spaces, that's the name of a method being tested. No spaces inside, returns the full length. Okay, so I create a new string calc. I call the method under test with a specific string, no spaces, and I assert that I get back 3. That's a very simple test, and all I'm testing here is that it checks the length of the string. I have a test that looks about the same here. It checks the same thing, only with a different string. I have basically the same test twice with different parameters. Now, I arrived into this because I was doing test-driven. And most people, if they were writing the test after, they would not write 2 tests, just write 1. And I'll explain why this is important. But first of all, look at the name. The name of the test actually says the same name as the first one, but it has a number at the end. This lets me know, as the reader of the test, that this is just another angle as another test with the same name. So the same test, different parameters. Because you're going to have tests that look very much the same, but different parameters. And throughout the day, I'm going to show techniques for refactoring that kind of code and other attributes that help with that kind of stuff. But this is a basic pattern. You write the same test with different parameters. You have to have a good name for that. I would use the same name with a number at the end. Let's look at the string calc class. It's just a very simple class. A length without spaces, takes a string, checks stuff, and so on and so on. It's very simple. These are all the tests for it. Now, if I open the IntelliSense, you can see that the naming convention also helps to group all the tests for the same method together. So I can look for all the tests and understand the specific scenarios without even looking at the code. So if I was doing a test review, which I highly recommend that you start doing, if you start writing unit tests in your company, start by doing test reviews. See how other people write tests. And if you are learning and if you want to teach them, a test review is one of the best ways. Because then you can see the test name and you can see how they write. If they write it crappy, you fix it right there and then. If people don't write good tests to begin with, we'll have a hard time fixing them later. You need to start early. Now, running them, there are several ways. The basic way is to run them with the runner from the test framework. So I can right-click here and I say test with NUnit. Or I can just open the NUnit GUI, which is installed with NUnit, which is an open source application. It's freely downloadable. This is the NUnit GUI. You guys okay with the fonts there? Okay. This is the list of tests. It's organized by namespaces and by classes. There are 3 parts here. This is where I click the run stuff. This progress bar, all the way here, turns green or red. There are no middle colors. So if even just one test would fail, this whole bar would be red. Here I would see all the errors from all the tests. Here I'd see stack traces and all that stuff. Let's just run them for a second. You can see they all pass. They all run in memory. They run very fast. There is a great add-in called testdriven.net. It's freely downloadable for a personal version. If you use it commercially, it costs money, but it saves a lot of time and money. By default, it allows you to right-click and say Run Tests. Let me just show you the menu. Looks like this. You also have a Test With menu. Now, the Test With menu also has some interesting options. The one that I use the most is this one and this one. So I either run the test or I run the test with debugger. The difference is that when you run them with debugger, you can just put a breakpoint in the test, right-click, test with debugger, and you step into the test. If you do it through NUnit, which is a different process, you have to attach to the process, put a breakpoint, and so on, which is kind of annoying. With MS Test, you have this kind of stuff built in. You can run the test with debugger or run them without debugger, so there is no problem there. The nice thing about testdriven.net is that you can step into any method. It doesn't have to be a test. For example, if I just put a breakpoint here, and I right-click, and I say test with debugger, I have no console application whatsoever. test-driven will create an instance of the class, invoke the method. If it takes parameters, it will send in the default values. So this saves you time if you want to start debugging some code really quickly, instead of creating a console application and all that stuff. So it's really, really useful. You can see that the string by default, can you guys see what's written there? Up above? It says null, by the way. But if you want to do some like ad hoc debugging, you can just write an empty method in some class, call another method, put a breakpoint, right-click, test with debugger, you're done. Saves a lot of time. Of course, you can do the same with tests. So that's one difference. That's one thing that I haven't seen anywhere else, not in the test framework, because this has nothing to do with tests. It's just a cool feature. Okay, so that was basically writing tests. Now let's write them test first. TDD is the act of writing the test before writing the actual code. The idea is to have 3 parts. The first part is that you don't write a piece of code without a failing test. So you start with a failing test, make it fail. This is kind of hard to get used to because we're not used to writing code that tests something that doesn't exist yet. At first, the code won't even compile. I'm going to write a test for code that may not even exist yet. Or if it exists, I know it doesn't work yet. Once I see the test fail, that is, I make it compile, I make it fail, I now make it work. I make it work as simply as possible. This is a big catch. Most people will make it work and then we'll make some like 500 other future tests work at the same time. Let's add a null check here. Let's add, what happens if they call us with a minus number or whatever? And there are no tests for that whatsoever. The point is to only solve the current tests, nothing more. Of course, you do have to think responsibly, but most of the time, you should not need to think about future features. And there is a big reason for this. You do not implement features that are not needed yet. Maybe you will need to implement them tomorrow, but you never know what happens tomorrow. In fact, it's kind of a risk to say that I'm going to implement a feature that has not been requested yet. Because tomorrow I will move to a different task which has much higher priority, reality will change, and all that code that I wrote has no meaning. So you end up with a bunch of code that you wrote that no one will ever use because no one ever requested. And if you do that for a long time, you end up with Word. Anyone ever used Word? 90% of Word is unused. People doesn't even know stuff exists there. But just imagine all the programmer hours and days and months and years that have gone into creating code that no one ever uses. This is called feature creep. And TDD is really great if you are really strict about it at preventing you from adding features no one requested. But it's hard to learn. You need to have someone with experience that tells you, stop. You're doing something extra that you don't need. So I saw the test fail. I saw the test pass. Now, if I have multiple tests or I just finished the code, I make the test pass as simply as possible. This is another important thing. I don't just implement just the test. I implement the simplest piece of code that could possibly work. And remember, simple does not necessarily mean stupid. It could just be very simple. If I implemented it simply, maybe it's not generic enough. I can always refactor stuff to make them work better, make them more readable or whatever. But now, because I have tests, I can change the code and I will know if I broke something. That's better than refactoring before you have tests. That's better than optimizing before you have tests. So think of tests as a safety net. Once you have them, you can do whatever you want, except add more functionality. For example, you have a parsing method, and now that you have it works, you can optimize the hell out of it. But you know that all the functionality still works. But you can now make it work, I don't know, with unmanaged C++, just if you really wanted to. But you would still know it works. Now, let's see some code in action. Let's implement a small feature in the string calc. This feature, I've chosen a specific feature, shouldn't be too hard. We'll implement a new method. It's going to be called SumString, sum S-U-M string. It will take a string with numbers inside it, 0 or more numbers with a comma between them. It will take all the numbers in the string and return the sum of those numbers. That's all I need. Sounds good? What's the first thing I need to do? Can anyone tell me what do I need to do now? Write the test. Well, you were perfectly correct. The last thing I need to do is to touch the code. First rule of TDD, you cannot touch production code without a failing test. And since I don't have any failing test, I cannot touch the code here. So I have to write a test. Let's write a new test here. Now, I'm working with ReSharper. So with anyone here use ReSharper, by the way? Okay. Anyone here ever created templates in ReSharper? Okay, most of you should learn this. You should be able to write a template that looks like this. Now, this is a template that fits MS Test. Let's see if I have a template that that fits NUnit. No, I'll change it later. Okay, so this is a template that has the three pieces of code. And if you wanted to learn how to create one, you go to the ReSharper menu and Live Templates. And right here is where I created a bunch of templates. This is the one that I'm showing. This is the code for the template. If you want, I'll post it on my blog. And the code is very simple. You just, well, they do have a bug with painting and that kind of stuff, but I guess they don't do unit testing. Okay, so this is the code. Let's change it to say test. So we just have code, and then we have place markers. Everything inside $, $, here, $, there, and anything inside it will be replaced. And then you can put macros in them and so on. So let's undo this and try this again, and now we have the correct test. So the first part is the method under test. What should be the name of the method under test? Now remember, I'm doing this test first. So if I've never gotten the request for the name of the method, I can decide on the name of the method. So what is the name of the method? Can anyone tell me if they remember? SumString. SumString, that's correct. And you get a t-shirt, sir. There are some t-shirts there. You cannot take more than one, by the way, unless you come wearing one. Oh, not yet. I'm just kidding. I'm just kidding. No, you can. You can. Okay, the name of the method is SumString. Now, what's the scenario? Okay, so remember, it can take a string with 0 or more numbers, and it returns the sum. Now, I can test multiple things here. So one of the things that you always encounter in TDD, what should I test first? Because there are many things that I can test. Can anyone give me an idea what they would write a test for? An empty string. Anyone else? Sorry? A null string. Anyone else? String with numbers. How many numbers? 3 or 4 numbers? Okay. Now, I have at least 3 options here, and I would usually choose the simplest one, but the simplest one that actually creates real functionality. That is something that I will be able to show. So, for example, I will not write a test for something that sends invalid values as the first test, because I can't just go to my manager later and say, hey, you know, this SumString method works great. I mean, it will handle any invalid number you give it. No, it doesn't handle any real numbers. No, no. Oh, but you got to try giving it some unreal number. Oh, you're going to love it. Okay? So you have to give real value to the customer. You can add all those other cases later. But the first point is to get something across that has value. So the simplest one I can think of is an empty string, which is a real scenario. Empty string. What's the expected behavior of an empty string? Return 0. Did I say return 0? No, I didn't. So this is a point where, because you have these kind of expected scenarios, you start to ask, hey, I didn't get a request for that. I didn't get a specification for that. So you think about the requirements better. And you go and you ask your manager or the person who gave you the spec. They say, oh yeah, it should return 0. So you were right. You get a t-shirt. Wow. How much time do we have left, by the way? Oh, now you say 5 minutes? Did you do the 5 minutes? He did the 5 minutes and I didn't even notice. Okay, next time, I want to go like this and jump. Okay, so that's the expected scenario is returns 0. Okay, now writing the first test should be very simple. I should first create new string calc sc equals new string calc. Now I can just call the method. Now the method doesn't exist yet, so I would say sc sum string. I would call it with an empty string. Now it will not compile yet, but I will make it compile and then I will see it fail. Of course, I would assert that something is true, or equal to 0, the actual result. I can't even compile this. Let's make it compile using ReSharper. I'm just going to use all those shortcuts that I like. String, numbers. Now I need to see the test fail. So by default, I'm going to return an invalid value. Return -1. Now why -1? It's the first invalid value I could think of that's closest to the real result. And I'm going to run the test. I'm going to run it using test driven, and as I run the test, you can see that the test fails, and you can see that 4 have actually passed. 4 passed, 1 failed. Expected 0, but was -1. This is part of the test framework. That's the message that it gives me. Okay. So now, what happens? I have a failing test. I have permission to go to the production code and make the test pass. But remember, I have to make it pass as simply as possible. So what can I do here? Sorry? Return 0. Okay. Anyone else? No, I said anyone else with a different answer. But thank you very much. That was very helpful. Check if the string is empty. Did I have a test for check that sends an empty that sends like a string that is not empty? Then why should I check it? Aha, you see what I mean? You see what I mean? Okay, you know what? Let's return 0 just to see what happens. Now people will see this and they will react. They say, I would never write code like this. You know, let's just run the test. Just to make sure. Okay, they all passed. So we have real functionality. Congratulations. We handle empty strings. I'm not kidding, actually. We have real functionality. We only handle empty strings. Now, I know and you know this code is crappy. Can I go and change it now? No. Why can't I go and change it? Sorry? What works? Why can't I go and change it? I don't have a failing test. First rule of TDD. Okay? So if I want to change this crappy code, what do I have to do? Write a new test. Let's write a new test, because I can't live with this. Can you? Okay, let's go and change the test. Not change the test, I'm sorry. Always create a new test. This time, how do I prove this code is crappy? What's the simplest test? Come on. Simple test that proves this code is not good enough. What? Not null. I'm talking about real functionality. Let's send a string with a number, right? We know it can't handle numbers. So, one number. And it should return that number. Does that make sense? What am I missing here? Returns that number, returns number. What am I missing? The brackets above? I'm outside the brackets. Ah, you see, this is pair programming. No. Did I write an extra bracket there? Just as a problem? Okay. Okay, returns that number. Let's run all the tests. Did you notice that I forgot to do something? I forgot to change my test. That's why copy-paste programming never works. So I'm expecting 1. And I'm running it, and I'm going to get expected, and then it failed. So now I have a failing test, and I have the option to go and start changing the production code. So I go to the production code. By the way, you know we won't have time to do a song, right? I'm going to do 2 songs on the next session then. But this is really important. I want you to see this first. Okay, I go to the sum string. I have the option to change it, make it uncrappy. What do I have to do? The simplest code that would work to make all these tests pass. All those 2. Come on. What could I write here? Int parse. That's cool. Int dot parse numbers. Awesome. That's simple. That's elegant, right? Let's run all the tests. Oh crap. I think we have a bug. How can we have a bug in 1 line of code? Input string was not in correct format. Let's look at the name of the test. Aha. Do I need to debug the code to fix the problem now? Who thinks I need to debug the code now? That's my point. So we're not handling empty string correctly. Int parse is not good enough. Most people would think it would be good enough. They wouldn't even test it. But because I have good code coverage, I now have the simplest test that actually fails. That's the first one. So I now have to do like a simple check. The simplest one I could think of was if numbers length equals 0, return 0. Now I once had this guy at the class that said, just return the length of the string. And I said, dude, that's sneaky. That's not simple though. That's just sneaky. It's cool though. It's cool. It's like a C++ hack. It's like a macro. Okay, let's run all these tests. And we now have a feature that works partially. We work with empty strings. We work with 1 number. We can test it with more numbers and so on. And we can continue on to develop this feature. But notice that we're working incrementally. We always have something to show. Even if it doesn't work fully, I know what can work and what can't work. Okay? This is the basics of test-driven development. We are out of time. I thought we might have some more time for questions. But let's take a short break. And we come back. If you all come back, we're going to do some unit testing best practices. Thank you very much.